Cantor's diagonal argument, the real numbers between 0 and 1 are uncountable. Assume, for contradiction, that we can list every number in the interval as a sequence, first, second, third, and so on. Write each number in decimal form. Highlight the diagonal digits, the first digit of the first number, the second digit of the second, and so on. Build a new number by changing every diagonal digit. Rule: if the digit is not 2, write 2, if it is 2, write 3. This new number, 0.232322 and so on, differs from the nth listed number in the nth decimal place. So it cannot appear anywhere in the list. The assumption that we listed all reals is false, therefore the interval is uncountable. The same diagonal idea shows the power set of the naturals is bigger than the naturals themselves. If every subset is f of n for some n, define T as the set of n such that n is not in f of n, then T differs from every f of n about membership of n. Contradiction. Countable lists cannot capture every real, nor every subset of the naturals.